Thank you very much. When I was 10 years old, I used to live in West London in Shepherd's Bush. And every Saturday afternoon, I used to go to Shepherd's Bush Market. I was very keen to see what people were selling, what they were buying, but most importantly, what they were throwing away. Because frequently, among other people's rubbish, I could find something useful for myself. For instance, a box from which I could make a cricket bat. But every Saturday afternoon at Shepherd's Bush Market, there was a very strange man. He was selling medicine. He was selling medicine in little bottles like this, and he told everyone that this medicine was the best medicine in the world. It could cure you of any problem which you might have, a headache, toothache, muscle pain, rheumatism, neuralgia, even nostalgia. And the reason, he said, why his medicine was the best medicine in the world is because unlike many other medicines, this does not contain any acid. And everyone knows that acids burn. Now, he had some examples of medicines which contain acids to show to people. He had, for instance, some Brittle seidlitz powders. These are used to treat constipation. Read the label on the side. These contain tartaric acid. Acids burn, he would say. And then he had some Andrew's liver salts. Andrew's liver salts are used to treat indigestion. Read the label on the side. These contain citric acid. Acids burn, he would repeat. And then he had some aspirins. Aspirins used to treat a variety of minor ailments, migraines, headache, toothache, etc. Read the label on the side. These contain acetyl salicylic acid. Rather than telling you what this can do in your stomachs, he said, I am going to show you. So he took out 2 aspirins and he placed them on the palm of his hand, and then he placed them onto some crystals which he had in the open air every Saturday afternoon at Shepherd's Bush Market. And then he said, when you have a toothache or a headache, it is entirely possible that you may also have a sore throat, in which case you might like to take some cough syrup. And he had a bottle of Sanatogen baby cough syrup. He then put some of the syrup on, and then he said, you may not like the taste of these medicines, so you might like to drink some water. So he sprinkled some water on. And then he said, watch carefully, because in the next few seconds, you're going to see how this horrendous medicine, what this could do, containing an acid, what this could do in your stomach. And then suddenly it started steaming, and suddenly it started burning, and it burst into flames. And when people saw this at Shepherd's Bush Market every Saturday afternoon, they were terrified. They said to themselves, I don't want to have that happening in my stomach. So do you know what they did? They started fumbling and bumbling around in their pockets until they found one of these. This, my dear friends, 2 shillings and 6pence, half a crown. It was a lot of money in those days. And everyone, every Saturday afternoon, used to buy the magic medicine man's magic medicine. But I, as a 10-year-old, I was very lucky. You see, I was never ill, so I didn't need any medicine. However, I have to tell you that ever since I had been a tiny baby, I had developed a serious psychological malfunction. I had developed a secret and passionate obsession with fire. Now, my parents had bought me a chemistry set when I was 8 years old. And I used to mix all the ingredients together in the chemistry set in an attempt to make fire. But all I succeeded in making was color changes, fizzes, pops, and smells. Nothing like the magic medicine man at Shepherd's Bush Market. So I decided I would try to repeat his experiment. Now, I knew where I could get the aspirins from. They came from Boots the Chemist in Uxbridge Road. I knew where I could get the Sanatogen baby cough syrup. That too came from Boots the Chemist in Uxbridge Road. I knew where I could get the water from. It came from the tap. But I didn't know what those crystals were. So I decided to try and find out. I went along to Shepherd's Bush Library, and there I borrowed a book which was called Chemistry Magic. In that book, I started reading about all the recipes and mixtures which are used for making fireworks, pyrotechnic mixtures, to see whether there was a substance in there which resembled the appearance of those crystals there. And you know, there was a substance. It was called potassium permanganate. So together with the other medicines, I procured some potassium permanganate. I set up the experiment in my mother's kitchen at 44 Stanley Road, Shepherd's Bush, London, W12. And within half a minute, the whole thing burst into flames and filled the entire kitchen with smoke. That, my dear friends, was the greatest moment of my life. For it was my first ever truly successful chemistry experiment. And ever since that day, I have been conducting chemistry experiments on an everyday basis. And that is what I have come to talk to you about today. The science of chemistry. So what is chemistry? Chemistry is the science of substances and how they turn into different substances. And very frequently, we can recognize a chemical change because there is a change of color. As I pour my water from one flask to another, you'll notice it's changing color. And the reason why it's changing color is because it is making a new substance every time. Thanks to the science of chemistry, today we live in a splendid world of plastics, polymers, glues, adhesives, drinking water from the tap, fertilizers, cosmetics, soaps, detergents, shampoos, a whole range, fuels, pyrotechnics, mixtures, explosives, a whole range of wonderful substances, thanks to the science of chemistry. Chemistry, the science of substances and how they turn into different substances. And here I have mixed together some chemical waters and shown you examples of recognizing a chemical change by a color change. But here I am going to move over to something completely different. In my flask I have here, which is something which represents what the magicians used to call magic disappearing water. The reason why they call it, because you throw it up in the air, stand underneath it, and it disappears into thin air. And this, of course, as I'm sure you all know, the reason why it disappears into thin air is because, of course, it is made of thin air. It is, in fact, liquid nitrogen. And we can say in Deutsch, das ist flüssig Stickstoff. Ich lerne Deutsch seit 3 Monaten nur für heute. Also, mein Deutsch ist nicht so gut. Ich hoffe, bald besser Deutsch zu sprechen. Jetzt werde ich weiter English sprechen. So I'm sorry I continue in English. I have done my best. So here we have, of course, liquid nitrogen, which represents one of the greatest discoveries of the science of physics. Physics, of course, is the science of matter and energy. And what I'm doing here, I'm pouring some liquid nitrogen into 3 bottles, which I have here. You will notice that the liquid nitrogen, as it sits in the beaker here, it is continuously boiling away. The reason why it is boiling away is because it has a very, very low temperature. Boiling temperature is minus 196 degrees centigrade. And that, of course, is much colder than we have here, which is about 24 degrees. Sorry, I'm just adding a little more. Some of it's missing, but that's of no great consequence. So we have there, we have a little bit here, and we have a little here. Now, one of the golden rules when you have a liquid which is boiling is never ever to lock it in an enclosed container, which is exactly what I'm going to do now. I have put the liquid nitrogen in here. There is about 100 milliliters of liquid nitrogen in here. I have put it in the bottle, and when any boiling liquid expands, it expands by a factor of approximately 800. So therefore, 100 milliliters of liquid nitrogen will expand to a volume of approximately 80 liters. And this is a half-liter bottle, so it will generate a pressure of 160 atmospheres, which is a very substantial pressure for a simple plastic bottle like this. And therefore, there is a real chance that this will explode, that this will not explode as soon as the pressure has built to about 5 or 6 atmospheres in here. I am now therefore putting them, because the bottles may well explode, I am placing them in these dustbins. And I can ask you to use your common sense to detect which lid will fly off the highest, looking at the sizes of the dustbins. Now, this will take approximately 7 minutes. In the meantime, I would like to show you a couple of other experiments with low temperatures. Well, first of all, obviously, we must freeze some water. So I'm going to pour some water in here, into my beaker here, and I will now cover it with liquid nitrogen. So we just place this in here. I will place my glove on because this is quite cold and you can get very severe frostbite. And we have here an interesting demonstration in the science of physics. And the reason why is because physics, the science of matter and energy, I have mixed here together 2 colorless liquids, but there is no change of color. There is no substance being produced which is new. We have here, by contrast, a change of state. The liquid nitrogen is changing to a gas, and the liquid water is changing to a solid. So we have the 3 states of matter in one beaker. So this will continue, the water will continue to freeze, and while that is freezing, I will move on to the next experiment with low temperatures, which involves a piece of rubber tubing. Now, rubber is a solid, but it is an elastic solid. If I stretch it and let it goes back to its original shape. And the reason why it's elastic from a thermodynamic point of view is because we have a lot of energy. At the temperatures of this room, there is a lot of energy. The molecules have a lot of movement. However, at the temperatures of liquid nitrogen, there is very little energy. And so as I put my rubber tube into this liquid nitrogen, please watch carefully what happens. And there you see there is a fountain of liquid nitrogen issuing from this balloon. Now, why does that happen? Well, as I explained, when a liquid boils, it expands by a factor of about 800. It's expanding inside the rubber tube, setting up a pressure which forces the liquid nitrogen out. Now, in those bottles there, the liquid nitrogen has nowhere to go because the gaseous nitrogen has nowhere to go, so therefore we may expect an explosion. So that's what has happened to our piece of rubber for the liquid nitrogen, but we can now inspect the elasticity of our rubber tubing. And if I put it down here, you'll notice that the rubber tubing, excuse me, I need to hit it against something proper. Here is a piece of metal. And there you see, it shatters into 1,000 fragments. Now, oh, that's okay, I did warn you. They are going to go bang, and it's not a problem at all. As I was saying, expect 2 more, by the way. And I was about to explain, why does the rubber tube shatter and become brittle? Once again, we go to the science of thermodynamics. And the reason is that at high temperatures, all the molecules vibrate a lot. So they're going like this. I'm vibrating, I have lots of energy. But at a low temperature, suddenly the movement ceases. The molecules stop moving. And the reason is they have very little energy because of the low temperature which they have. And we can show you another experiment in this department with a balloon which I have. Now, here, of course, our water is frozen, almost frozen. There is a little crackling, but I would like to show you an experiment demonstrating once again. Sorry, my balloon has fallen off the stage. You must excuse me, we have a draft here, and I have to jump off the stage just to recover my balloon. This balloon will shortly stop flying. Now, why does this balloon have this beautiful shape? Because the air inside has pressure. Why does it have pressure? The molecules are moving with a velocity because they have a warm temperature. However, and the temperature causes them to move, and as they hit the membrane, they generate a pressure. But as we lower the temperature of the balloon, so you will notice that the balloon gradually collapses. Now, the reason why it collapses is because there is a very low temperature. At low temperatures, there is very little energy. And therefore, the molecules strike the membrane with very little energy indeed, and therefore the pressure is reduced, and so the balloon collapses. And of course, we can demonstrate this by putting even more liquid nitrogen on our soil. I'll get it to collapse as much as I can in these circumstances. So there we are. So this you see, but this is a physical change. And if we now take the balloon out and just warm it up a little bit by just striking it a few times, throw it up in the air a few times, then in a very short space of time, the balloon will restore its full shape. And the reason why it does so is because as it warms up, so the air inside, the molecules of nitrogen and oxygen, have greater energy, they move more rapidly, and so they strike the membrane of the balloon with a greater velocity and exert a greater pressure. Excuse me, no, I'm carrying on. Now, I'm moving on to my favorite topic, which of course is fire. And I wanted just to show you that a burning candle like this represents one of the greatest triumphs of early human civilization. For it was in East Africa 100,000 years ago where first intelligent humans established their existence, human culture began, that people for the first time were able to make a flame like this and to burn it and sustain it for a long time. What I'm now going to do is to show you how, thanks to the science of chemistry, we now make remarkable flames which are much, much better than this. I'm just going to throw my balloon away because I don't need it any longer. I'm going to first of all show you how a piece of cotton wool burns. When it burns in air, it is a dreadfully boring experiment because air only contains 20% oxygen. The discovery of the fact that air is a mixture of gases is one of the greatest triumphs of the science of chemistry. This was made about 250 years ago. This cotton wool is burning like this. It's surrounded by air, which only contains approximately 20% oxygen. And that's how it burns. That's how it's been known to burn for thousands of years. However, in 1846, when German organic chemistry was at its great strength, German chemists, specifically, it was in fact Professor Christian Schönbein of the University of Basel in Switzerland, who made for the first time a new type that was able to chemically combine cotton with oxygen to make it burn better. So if I now show you a piece of cotton which has had oxygen chemically combined with it, please observe how this burns and see if you can spot the difference. So there it is. There you see an instantaneous combustion. Now that's, of course, Professor Christian Schönbein, University of Basel, 1846. That was the discovery of the high explosive. It was a new era in the science and technology of the world we live in, and thanks to it, it has completely revolutionized our planet. The exploitation of fuels with the understanding that air is a mixture of gases, primarily nitrogen, let's say 80%, 20% oxygen. Now I have shown you a small piece of gun cotton burning. I'm now going to show you how, using this device here, which is a mortar, I'm going to propel using a gun cotton fuse, which I have a gun cotton propellant in here, how I'm going to propel 4 ping pong balls, hopefully high up into this beautiful auditorium here. Now this then is a mortar. It has a hole in the bottom, and this is the device that's used for all major fireworks displays. I'm going to drop my explosive charge to the bottom. There it is, it's hit the bottom. I'm now going to put in 4 ping pong balls, 1, 2, 3, and 4. I am now going to put this here. I'm going to just very quickly put a fuse here, and hopefully we will observe this flying up to the sky. Please excuse me while I grab a splint. So as I said, the discovery of oxygen revolutionized our usage of fuels. Now that will continue to burn. I'm moving on to the end now. Please watch. I hope it works. You should hopefully see them shooting out somewhere. And there we are. They went up somewhere. The ping pong balls went flying. So once again, a successful application of the science of chemistry. One of the greatest discoveries, one of the great gas chemistry Gas chemistry, you know, I am particularly privileged to be talking in front of an audience here in the city, which has, of course, given birth to two great Nobel Prize winners in chemistry. One of them was Fritz Pregel, who has received the Nobel Chemistry Prize in 1920 for his work on organic chemical synthesis using microanalysis, and the other was the great Walter Nernst, who was a German chemist who did his PhD here at this university here. So Graz is the birthplace of two brilliant Nobel Prize winning chemists, and I'm sure there are many more amongst you here today. I have in this balloon here, I have here some hydrogen gas, which is the greatest, oh sorry, my flame is going out, I cannot control myself. There's a very strong wind blowing here. This is the ventilation, so if you excuse me, I'm just going to set fire to this once again with the hope that I can ignite my balloons. Now, gas chemistry and the study of gases made great advances towards the end of the 18th century. Once gases had been isolated as individual substances, the chemistry and the physics of gases became of paramount importance. And that's, in fact, what led, it was the physicists who were able to convert to make liquid nitrogen. Now, here, and here, I have pure nitrogen, pure hydrogen. This is Wasserstoff, and it was first discovered or recognized by the eccentric English chemist Henry Cavendish in 1766, and it created a sensation in scientific circles because it could float upwards. But it burns with a beautiful orange flame in air. Please watch carefully. There it is, and it makes a loud puff, and it makes some water as it does so. Now, in this balloon here, I have something much more dramatic. In this balloon here, I have a mixture of hydrogen and oxygen. Now, this Pilatre de Rosier, the French engineer, he used to call this aria tonante, which in Italian means thunder air. This is a stoichiometric mixture, and it will make a very, very loud bang indeed. So please listen carefully. This is thunder air. So there it is. So that's that one there. And now I'm going to just for the, no, this is, please, this is, everything here is very, very dangerous. And now for the final demonstration here, I'm going to use the fuses which I made. I have here two balloons. They are both filled with a mixture of hydrogen and oxygen. In other words, they are both thunder air, aria tonante. And the one is at one end and the other is at the other end. I'm going to, sorry, I have to move things away because the explosion may blow everything over, so I have to take great care. And here, I will now lay a fuse. This is a fuse of nitrocellulose, otherwise known as gum cotton, and I'm laying it across here, and in order that it can set fire to the balloons. So I have got my fuse laid there, and that will hopefully set fire to the balloons. But to have just a thunder effect would not be much fun without some lightning. So I'm going to prepare here. I have a mixture of magnesium powder and potassium chlorate. I'm going to put on safety specs for this. Sometimes it explodes as you mix it, so I have to take great care that I don't blow it up in my own face. So at least if it blows up, at least my eyes are protected. So I'm mixing this together now. I'm making, this is as I said, a flash powder from potassium chlorate and from magnesium powder. It's too dangerous to use in pyrotechnic mixtures. And when you use it, you simply mix the two bits together like that. So I'm going to now place some of this here, and I do have to warn the audience, this makes a very, very bright flash. So if you're sitting in the front, then you may like to take great care not to look at that directly. I shall be, but that's my job to be here as a care. So I shall be lighting this from here. You will hopefully see a yellow flame, two bright flashes, a massive cloud of smoke, and then a very loud bang. So that's what I'm hoping to achieve. And before I finish off, there is a moral to what I've been talking about. So to summarize, I'm just going to light this in here, and to summarize what I've been talking. What have I been talking about? Chemistry. What have I been selling to you all? Chemistry. In plain and simple language, chemistry for all. So there it is. Thank you very much for your kind attention. I have finished everything I wanted to say. Thank you very much indeed. Thank you very much. A short chemical demonstration. We are all alive and well, and we have survived. Thank you very much.
Andrew, that
Thank
was
you. We are all alive
absolutely
still.
amazing.
I'm honored. Thank you.
You told me that you belong to the University of the Human Spirit, and I've got to tell you, I think we're now all part of that, and we all want to enroll.
Thank you very much.
So, as you know, this conference is all about curiosity and the future belonging to the curious ones.
Yes.
I want you to share some of your curiosity with us, and how do you stay curious?
I just love doing chemistry experiments. So I love watching changes occur rapidly. That was, and most importantly, as I told you, fire. Fire is the most spectacular. It's been known throughout the history of the human race to be both infinitely destructive and infinitely constructive. Today we make use of fire in the form of energy for all motor vehicles, jet engines, anywhere where a fuel is burnt, domestic central heating systems. In every one of those systems, we exploit brilliantly the energy produced through the combustion of the fuel through an understanding of the fact that air is a mixture of gases for our benefit. And that's thanks to that discovery of air being a mixture of gases some 250 years ago. We're looking at the late 1770s, and it was the great French chemist Antoine Laurent Lavoisier who formulated today's theory of combustion, from which we all benefit on an everyday basis.
I love the way that you look at that and how you can help all of us start to understand that things that happen in our world today, it's taken hundreds of years for us to get there.
Exactly. Well, I couldn't agree. Well, this is the whole point of my teaching philosophy. I stress throughout my teaching the importance of the historical development of the understanding of science. So science and technology, as it has evolved, in today's teaching systems, there is very little mention. In England, there is no mention whatsoever of the history of science in any of their chemistry, physics, or biology syllabuses. So what happens? Children go to school, they learn, 2H2 plus O2 makes 2H2O. C plus O2 makes 0. Anyone could do that. It's easy. No, it's not easy. It took thousands of years to discover. Today, science and technology, education in England have lost their dignity. And they've lost their dignity because children learn by formulae. They just learn to answer questions, etc. When I studied chemistry 50 years ago at Latimer Upper School in Hammersmith, I knew about Kohlrausch's law of independent ionic mobilities, Dalton's law. I learned about Humphrey Davy, Michael Faraday, Perkin. I learned a whole load of names. Now, the names were abstract to me, but I knew there was a name behind. Today, they don't even know a single name. So chemistry teaching has been dehumanized. And that's the problem that we have in education. So today, people come, they've passed their exams, and, hey, I'm great at chemistry. No! You know nothing. You've just learned to understand. And that's what the problem is today. It's all too easy. They've been making it easier because they want more students to do chemistry. No, what you want to do is you want to keep it difficult so that the best students can at least then flourish. But in England, if everyone gets an A star in their examination, well, then there's no selection. Then everyone has to get a top grade because everyone has to be clever. And that's the problem we live. We live in times nowadays when no one knows anything about anything and everyone is terrified of everything.
I do have to say something, Andrew. If you were my chemistry teacher, I think I would have paid a lot more attention.
Thank you very much. I'm honored.
So, and I see a few nodding heads. We do have some microphones in the audience, by the way, in case anybody has any questions. I know Galit, who's waving her hand over there, has one, so if you can come to the front. I did hear a few laughters, though, so I quickly turned around and noticed that somebody had written, so you're a teacher. Have you ever considered Breaking Bad and making high-grade meth?
Thank you very much. Thank you very much. No, the only thing I've considered is in making high-grade explosives, and that's far more relevant, and I've just showed you a little example of it here.
Absolutely brilliant.
So thank you very much for your kind, one of my best, just to tell you, my very best friend, friend, I won't tell you his name, doing a PhD at a university in England. He did start making the stuff, and he got 2 years in prison because he got found. He was a brilliant organic chemist. Whole career ruined because he got found out making amphetamines. So
Wow.
it is very risky when you start being naughty. I am naughty, but I've got away with it.
I love it.
Don't tell anyone.
Nobody heard that. Yeah. Galit, did you have a question for us?
Yeah, so maybe I shouldn't ask that, but what is your dream experiment, or in other words, what would you like to set on fire?
What was my, favorite experiment?
What is your dream experiment?
Oh, my dream experiment.
What would you like to set on fire?
Oh, what would I like? You know what? That's a very good question. The answer is, my top priority with everything I burn is really safety. I have to say that because because I have to be very careful not to set above all myself on fire. So my criteria is, what's the biggest fire I could do without burning myself? Well, I've got pretty close to doing them here today, you see. I could probably have gone one step up, but then that would have been putting you at risk. The honest truth is, anything to do with fire, I suppose, has really been my passion, and that story at the beginning. By the way, can I just explain the story of the Shepherd's Bush market? This was a complete fraud. It was a complete fraud. The man was using, today nothing has changed. People frighten you into buying insurance, buying cosmetic things, medicines that you don't need. Nothing's changed. He just had that experiment has nothing to do with aspirin, and it's got nothing to do with water. It's just a straightforward oxidation of propane 1,2,3 triol, which is glycerine, which is used in cough syrup, and with the potassium permanganate, KMNO4, which is a powerful oxidizing agent. And that is trickery once again. All the time, every day, we are being tricked by various people trying to get money of us, by frightening us, by giving us all sorts of stories. And it is the survival of the fittest. He who dares wins. I am hoping to win.
So,
yes.
Andrew, I love that you just mentioned stories.
Yes.
Because I know that you've got quite a few stories to share. And if I'm not mistaken, didn't you just launch a website, or in the process of?
Yeah. That's funny. I don't know how you found out. Because but in preparation for today's talk, I got one of my best friends, Roxana, to design a website for. You see, I'm very out of date. I have only for the first time on this trip used a modern mobile phone. I used to have a Nokia brick until 2 days ago. But my children and my wife said, get yourself a proper phone, Szydlo, because you'll need it. You're going to Austria by yourself. I had to use it all the time because I drive all my cars are over, I have 8 cars, all of them are over 45 years old because I believe in repairing them. My motto is, and I teach this at school because I teach automobile mechanics, if man made it, man can fix it. So we learn to repair our own stuff, you see. So I came over here and then I said, well, this is a good opportunity for people to get to know me better. So Roxana set up a website for me, and I put on the wackiest photograph I could find of myself doing a chemical experiment. And then, in case any of you ever look at it, I look really stupid, like breathing the most poisonous gases in the world. I had, in fact, made liquid nitrogen dioxide from the decrepitation of lead nitrate, which no one knows about today because it's been deleted. It's one of the best experiments in our repertoire. And you know what? I've launched a series of experiments in our school called Obsolete chemical experiments. It's experiments that no one does. They were deleted from the syllabus 30 years ago because they were too dangerous or too smelly or too difficult. I now do the whole lot. And I'm the only person in the world who I think does them. Isn't it extraordinary? Sad. So yes, I do have a website, and as I said, there's a picture of me breathing what appears to be liquid nitrogen dioxide, which will be, of course, I wasn't breathing it in, I was holding my breath and breathing out. But it looks pretty gruesome, and if you're afraid of things like that, don't look at it. Thank you very much.
Should you suggest we try these experiments at home?
No, you shouldn't try these experiments at home, no. Thank you very much for your good advice. But, the Americans have put masses of brilliant stuff on YouTube, and it really is very professionally done, of the very, very highest standard. And I'm full of admiration, but it seems that the Americans are the main country that are putting up very, very interesting experiments. And I do learn a lot from them myself.
So how do you continue to learn and how do you keep yourself curious?
Thank you very much indeed. That's a most good question that you've asked me. I'll tell you why. How do I keep myself curious? I keep reading. I collect chemistry textbooks. One of my favorite hobbies is collecting chemistry textbooks and reading about the history of science and the history of chemistry. And that is unbelievably rewarding because it enables me to understand even more about the fantastic heritage of science and technology that we have today. And in fact, through all of that reading, I have come up with an idea to revolutionize the way science is taught in schools throughout the world. They should scrap chemistry, physics, and biology as compulsory subjects, and they should introduce as a compulsory subject history of science and technology for all children in the world. And then they would learn from the earliest origins of ancient Egypt, Babylonia, Greece, Rome, Middle Ages, Science Revolution, and all children would still do fantastic experiments, but they would then understand how long it took to achieve everything. And then chemistry, physics, and biology would continue to be taught, obviously, at a higher level, in other words, what it was 50 years ago, for those students who wanted to carry on. But my message is, teach history of science and technology to every child in this world, and the world will be a better place to live on.
Love that.
Thank you very much indeed.
Thank you.
Right.
So I just have to say, Andrew, you are one of the most interesting and curious people I've ever met. On a side note, if you get a chance, ask him afterwards. He fixes his own cars, so he drove all the way here from Britain. He also collects, if I'm not mistaken, bees, and you make your own honey,
yeah.
a beekeeper. And he's also a musician. His curiosity doesn't stop. Like, he's just absolutely incredible.
Yes, I'm a violinist.
But I do have to say, one
Mozart,
of the...
fantastic. Bum, 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 bum. Yes, sorry.
No, all I was going to say is that I couldn't agree more, is Graz absolutely loves you.
I'm very honored.
Your passion and your energy is catching.
Thank you very much.
Thank you so much for taking the time to come be with us.
Vielen Dank.
I think everybody should stand for Andrew.
Thank you very much indeed. Thank you very much. Thank you very much indeed. I'm very honored. Thank you very much indeed. Thank you. I salute you.